The output from the build OpenCL native script is an executable called OpenCL matrix multiplication. This will carry out a multiplication of an m by n by an n by p matrix. It is found in the /op directory. We will run this executable with its default values, which are m equals 8, n equals 8, and p equals 8. When you run the example, it will try three different kernels: the naive matrix multiplication, the transposed B matrix multiplication, and the OpenCL vector 4 type matrix multiplication, which is our most optimized version. Scrolling back through the results, we can see the various timings that were used to generate the information in the document. The first thing the log shows is the value of m, n, and p that are being used. So in this case it is 8, 8, and 8. For reference, it then shows the timing of the optimized ARM Neon implementation of the multiplication, which in this case is 0.05 milliseconds. Each of the kernels is run 4 times, and the value we're looking at is the actual kernel time, which is the time spent in OpenCL doing the execution. This can be compared to the CPU side native multiplication value to see any benefit we have from using OpenCL. In this case, with very small matrix sizes, it is a lot slower, and also there is no benefit to the different optimizations. The table at the end, called the Hall of Fame, shows the results of all 12 of the matrix multiplications with the 3 different kernels listed in order of time. With a very small 8x8 by 8x8 matrix, the overhead of OpenCL is by far the most significant factor, and so the actual compute times are basically the same for all the different kernel types. So that's between 1.28 and 1.48 milliseconds. We can increase the size of the matrices being multiplied using the command line options -p, -n, and -m. In this case, we're going to increase each of these to 64 and then see what difference it makes to the behavior. With these matrix sizes, the Neon implementation is 1.04 milliseconds, and when we look at the OpenCL ones, we can see that because we're now doing more compute, the vector 4 optimized type is now significantly quicker than the other 2 naive types which do not use the SIMD instructions. So it's around 7 milliseconds compared to the 2728 for the unoptimized version. The key point to remember from running this example is that the OpenCL implementation is not quicker. In fact, it's significantly slower than an optimized Neon implementation on the ARM. What the advantage of OpenCL on the BeagleBone is that we can use the SGX 530 core to offload the ARM for activities that are not time critical, which allows the ARM to be doing other more time critical tasks.